Welcome to this explainer. We're tackling something today that honestly feels a bit like pure science fiction, but underneath it all, it's driven by incredibly brilliant, elegant logic. We're going to completely open the hood on artificial intelligence. If you've ever used tools like ChatGPT or Midjourney and felt like, I don't know, there was a tiny wizard doing digital sorcery inside your laptop, you are definitely not alone. But here's the secret. Once you actually understand the math and the mechanics driving these engines, you stop being just a user. You become a master of the machine.
Okay, let's dive into this. Here is our roadmap. First, the AI black box. 2, LLMs, predicting the future. 3, diffusion, sculpting with noise. 4, RAG, the ultimate researcher. And finally 5, mastering the machine. Let's get started.
Section 1. The AI black box, exposing the illusion of magic.
Look, it is incredibly easy to project human traits onto AI, mostly because it speaks our language so fluidly. But to truly control these systems, we've got to strip away that illusion. There is a sheer, fundamental difference in architecture between the tech of the past and what we have today. For decades, our older technology relied on rigid, hand-coded logic and exact keyword matching. If A happens, then do B. But the new AI reality, it completely abandons those rigid rules. It doesn't actually know facts the way a traditional database does. Instead, it operates entirely on probabilistic prediction. It navigates these massive conceptual vector maps to mathematically guess what should logically come next based on pattern recognition. It's a complete shift from concrete rules to fluid probabilities.
Section 2. LLMs predicting the future. The engine behind ChatGPT.
So think about it. How does AI actually write a sentence? When you type a prompt and you just watch the text instantly stream across your screen, it genuinely feels like there's a hyper-caffeinated little genius inside your computer rapidly typing out thoughts. But what's the actual mechanism making that happen?
Well, the answer is an autoregressive decoder. Now I know, that sounds super intimidating, but it's really just a neural network that generates text by mathematically predicting the single most likely next piece of a word. We call that piece a token, and then it loops. It is essentially advanced autocomplete on steroids. It predicts one token, feeds that result back into itself, and then predicts the next token based on that new sequence. It isn't sitting there thinking 3 paragraphs ahead. It is blindly, rapidly calculating the highest probability for the very next fraction of a word, over and over and over again.
But how does it know which word makes sense? That happens through tokenization. See, AI cannot read English. It translates human words into numerical vectors, mapping them onto a massive, multidimensional semantic map. This means concepts with similar meanings like, say, dog and cat, they literally live in similar physical neighborhoods on this mathematical coordinate map. And this vector math isn't just for words, by the way. Take ByteDance's Monolith framework. That's the engine behind TikTok. Instead of just mapping words, it maps you. Monolith uses these things called collisionless embedding tables. Basically, that just means every single user and every piece of content gets their own totally distinct mathematical identity without overlapping. And the crazy part? It updates your vector in real time. Based on instant telemetry like your watch time, how many loops you let a video play, the split second you hit skip, it uses expirable memory vectors to dynamically adjust your location on that map in literally minutes. It organically forgets your old interests and recalculates your new ones instantly, just constantly keeping the feed perfectly aligned with your attention.
Now going back to text, to ensure those word vectors make sense in context, the transformer architecture uses something called self-attention. It calculates query, key, and value vectors to absorb context from surrounding tokens. Think of it like a master translator walking into a crowded room. Before translating a single word like bark, the translator looks around to see if they're standing in a dog park or a forest, right? The word bark absorbs the mathematical meaning of its neighbors, ensuring the AI never confuses a tall oak tree with a golden retriever.
All right, Section 3, Diffusion, Sculpting with Noise, How AI Creates Art.
Let's totally shift gears here. Text generation and real-time recommendations are one thing, but image generation is a completely different beast. We've all seen those stunning, photorealistic images from Midjourney or DALL-E. But again, how does the AI actually draw a picture from scratch without, a virtual paintbrush? The reality is brilliantly counterintuitive.
The secret is latent diffusion. AI creates images by starting with total mathematical static, just pure chaotic noise. Then, it progressively predicts and subtracts that noise to reveal an image. Imagine a sculptor standing in front of a block of static marble.
They aren't building a statue from nothing. They're carefully chiseling away the noise, step by microscopic step, until the masterpiece hidden inside is finally revealed. Let's look at how this builds in practice. Step 1. The system generates a canvas of pure random Gaussian static. Step 2. A neural network called a UNet looks at that static, and guided entirely by the numerical vector of your text prompt, it predicts the exact pattern of noise to remove. Step 3. It subtracts it. It repeats this loop dozens of times. Your text prompt is essentially just the steering wheel, telling the AI sculptor exactly which pieces of static to chisel away to reveal the cat, or the sunset, or the spaceship you asked for.
And here is the magic number, 48. Why 48? Well, early models tried to do this complex math on every single pixel of an image, which required massive, incredibly expensive supercomputers. But modern latent diffusion compresses the image into a tiny 64 by 64 matrix first. It operates in this compressed latent space before doing the math. And that achieves a staggering 48 times computational savings. That right there is exactly why you can now run world-class AI art generators locally on a standard consumer laptop without, completely melting your motherboard.
Section 4. RAG, the ultimate researcher. Fixing the hallucination problem.
So we know large language models are great at talking, but they have a fatal flaw. They hallucinate facts. To fix this, the industry created a new framework that is actively replacing traditional Google searches. Because let's be honest, we all know the pain of typing a complex question into a search engine and endlessly scrolling past sponsored links, SEO spam, and pop-up ads just to find a single fact. AI answer engines fix both the hallucination problem and the search engine problem all at once. The solution is RAG, Retrieval Augmented Generation. Instead of relying on the AI's internal, sometimes flawed memory, RAG acts like an ultra-fast librarian. It darts out into the live web, retrieves the most accurate, up-to-date physical web pages, and hands them directly to the LLM. The AI then reads that specific, grounded data and writes a perfectly synthesized, factual answer for you, complete with footnote citations.
For really complex queries, things like Agentic ProSearch take this even further with a multi-step reasoning loop. First, it decomposes your big complex prompt into smaller solvable tasks. Second, it executes multiple live web searches, acting exactly like a human clicking through different browser tabs. And just like ByteDance updates user embeddings in real time based on immediate feedback, this AI agent actually course corrects its search path in real time if it hits a dead end. Finally, it synthesizes all that live cross-reference data into one single, cohesive, cited response.
And this brilliantly illustrates a total paradigm shift. Traditional keyword search forces you, the user, to do the heavy lifting, hunting for links, dodging ads, manually piecing together facts across 5 different websites. Answer engines completely invert the model. The AI does the hunting, the reading, and the summarizing. It hands you a finished product instantly. It literally reclaims hours of your life.
Section 5. Mastering the Machine. Practical hacks for everyday users. Okay, so now you know the math, the vectors, the real-time adjustments, and the retrieval under the hood. It's time to put on your driving gloves. I absolutely love this quote from our research. Vague inputs yield spaghetti outputs. LLMs operate on token probabilities, not politeness. We have this major tendency to treat AI like a human, right? We ask vaguely, we say please, we say thank you. But look, the machine just does not care about politeness, it only cares about mathematical probability.
This requires a completely crucial shift in mindset, moving from the beggar prompt to the boss prompt. The beggar treats the AI like a magic 8-ball. Can you please help me write an email? That gives the AI way too wide of a vocabulary, which causes highly generic outputs. The boss prompt, on the other hand, uses assertive commands, specific verbs, exact constraints, and clear formats. By saying, write a 3-sentence email to my boss demanding a deadline extension, you mathematically restrict the neural network's active vocabulary to a very specific set of vectors, and that dramatically boosts the accuracy and usefulness of the output.
So here are 3 rapid-fire hacks to boss the AI around right now. First, the Explain My Options prompt. Instead of letting the AI guess what you want and risking a hallucination, force it to build a comparison table detailing the trade-offs of a decision. That keeps you firmly in the driver's seat. Second, the persona hack. Tell the AI to act as a Michelin star chef or a senior software engineer. This instantly recalibrates its probability tables, pulling words only from that highly expert subset of its training data. And third, chaining prompts. Please do not stuff a massive project into one single prompt. Have it brainstorm in step 1, outline in step 2, and draft in step 3. Force sequential logic.
You are now firmly in control. We've peered into the black box together, we've translated the vectors, tracked the real-time data shaping those embeddings, and chiseled away the static. So, now that you know there's absolutely no magic, only incredibly elegant math, what are you going to build today? Go test these hacks out, and I'll see you in the next explainer.